Hello everyone. So I'll be making some videos, so it's like small lectures about a variety of math topics. So this lecture we begin with just some basics in number theory, so the divisibility and so on, the fundamental theorem of arithmetic. So just an introductory to the numbers and so on. So in order to be able to understand the next lecture. Um, to begin, we have some integer n. So there's also, if we have another integer d, we say that d is a divisor of n, or n is divisible by n. Notation, yeah, vertical bar. So there's some integer k, such that n is equal to k times k. So this is how we define a number the divisible by another number. For example, 6 is divisible by 3, and 12 is divisible by 4, 13 is not divisible by 5, and so on. So here, because the k we find is equal to 2, and here the k is equal to 3. So here this we read it as like d is divisor n, or n is divisible by d. Or n is a multiple of d. So all of these expressions describe the same thing. So we next get to the division lemma, which says that if we have some n and d, we can always find some unique pair of integers such that n is equal to n d plus r, where r equal to 0. So r is greater than or equal to 0, and that's less than d. So here the r we call the remainder of the division by d. So when we try to divide n by d, there doesn't have to be divisible, so there's some remainder number. This basically is our r. And as we said, so this pair is unique, so because of this condition here. So if this condition is not true, then we can keep increasing r by by d as much as we want, and we decrease them much as we need correspondingly. So this condition is what makes sure that m and r are unique. Example here, we have the 18, and try to divide it by 4. So here, and so we have the m is equal to 3 and r is equal to 1. Or if we try to divide the 12 by 5, 2 and 2. So this is the m, d, and r, m, d, and r. So basically this is it. Like if you want to divide 13 by 4, then we have a remainder of 1. And if we want to divide 12 by 5, we have a remainder of 2. And this is what I'll be using this notation for it. So n remainder d. So this expression is equal to the value r. And usually in programming, it's like we just iterate it. But here the remainder, make sure it's exactly the remainder and the smallest one. So the r has to be smaller than d and greater than or equal to 0. So basically that's the division lemma. Then I mentioned some theorem about. So first we talk about the prime numbers. So p is a prime number. Prime if it has exactly two divisors, 1 and p, and basically p. Yeah. So we have to have exactly two distinct divisors for p. So in that case, p is a prime number. So examples of prime numbers: 2, 5, 19. All of these are prime numbers. You can think of it like the prime numbers are the atoms or the main units of division, like in any number. So we can keep dividing a number by primes until we can divide anymore. So the prime numbers are the numbers we cannot divide anymore by any other number. So that's the idea of the prime. Then we have this theorem, let's say. So if a prime number dividing a product of two numbers, then this prime either divides the first number or the second number. And here so this or is inclusive, means like, so actually both conditions could be true. So for example, we have like 3 divides 15 times 10. Then we have like the 3 divides 15. So this is one of the cases. So this number is 150. What else? So if we have 3 divides, say 6 times 9. So here it's one of the cases where both numbers are actually divisible by 3. So yeah, so here is what we have. So this theorem, and the reason behind this theorem. So here, to the prime number, if it divides this product, it means it will divide one of the parts at least. And this has to happen because the prime number, you cannot like divide it into two parts or something. But since we can divide it into two parts, so it can be in at least like all contained in the A or the B. Because we can divide the P into two smaller numbers. So, so like say part A and part B. We can't have this case that like we have two different parts such that this part divides this number and this part divides this number. So basically the P has to be like fully contained in one of the numbers, at least one of them. It could be both. Next we talk about the fundamental theorem of arithmetic, which basically says like if we have some integer n, we can always divide it into a unique set of prime numbers. So there's p1, the power of e1, e2, power of e2, and ek times ek. Sorry, power ek. So for each number n, we can find this unique set of prime numbers to factorize. For example, the 30, we can factorize it as e power 1 times e power 1, 5 power 1. Then we have the, let's say, 51 is 3 power 1 and 17 power 1. What else? So, for example, 100 could be it's 2 power 2 times 5 power 2, and so on. For example, in case of this, let's say 51, there is no other set of prime numbers that we can find other than this one. So this set, that if we multiply it, it gets 51. Only this set. That's the main thing about the fundamental theorem of arithmetic. Okay, so I stopped this video here, and I'll proceed with more definitions and terminologies later on in the following lecture.